Hi everyone. So today I'm going to go through with you about motion graphs. Let's look at this scenario. Describe the motion of the car. So you're given the displacement time graph. How would the description of the motion be like? I'll give you 5 seconds to think about this. All right. So as you can see, uh, the position of the car remains at 75 meters for the 5 seconds. So the car remains stationary. The corresponding velocity time graph will be a flat horizontal line at 0 meter per second, and that is being drawn now. Now, scenario 2. How about this? Describe the motion of the car looking at just the velocity time graph. Again, I'll give you 5 seconds to think. All right. So, as you can see, the velocity of the car remains constant at 25 meter per second for 5 seconds. In addition, we noted that the velocity of the car is positive. This means that the car is moving in the positive direction. Okay, so how will the displacement time graph look like? So the car must start off at 0 meters. So let's put a coordinate at 0, 0. Now, in 1 second, because the car's velocity is 25 meters per second, in 1 second, the car would have covered 25 meters. So let's put in a coordinate at 25 meters at 1 second. And we can continue doing so. In the next second, the car would have covered another 25 meters, so on and so forth. So all these are the coordinates or the positions of the car at the different uh, timings. So connecting all this, we have a straight line graph that cuts through all these coordinates. Let's do some analysis on this scenario to derive something very, very important in this chapter. So follow my guiding question. Just by looking at the description, would you be able to tell me what is the distance traveled by the car in these 5 seconds? I'll give you 5 seconds to think about this. All right. So the distance traveled during the 5 seconds is simply just using speed times time to get 125 meters. Second question. If you just look at the velocity time graph, looking at the highlighted region, that is the area between the velocity graph and the time axis. Can you calculate this area? Again, 5 seconds to do so. You may pause the video if you need more time. All right. So by using a simple length times breadth formula, you can figure out that the area of this area between the velocity graph and the time axis is 25 times 5, 125. Notice a pattern here, 125 at the top and 125 over here too. So therefore, there's this uh, conclusion from this simple example. The area between the velocity graph and the time axis actually tells us about the distance traveled. All right, so this is something important that you should take note. So I put a star in the video. Now, let's do another analysis on the same scenario. Looking at the displacement time graph, I'll give you 5 seconds to determine the gradient of this line. You may pause the video if you need more time. All right. So gradient is found by using rise over run, and the rise, which is the height of the graph, is 125, and the run, which is the horizontal span of the graph, is 5 seconds. So using that, we get 25 meter per second. Now, do you notice something? This value and this value. All right. So therefore, from this simple derivation, we can conclude another key point here, where the gradient of a displacement time graph actually tells us about the velocity. So over here, there are two important key points that you should take note, and these two key points will help you greatly when you are analyzing motion graphs. Moving on, scenario 3. This is the velocity time graph, which is given to you. It's a straight line that is going upwards. Description of the motion of the car. The car accelerates constantly from rest to 50 meters per second, moving in the positive direction because the velocities are all positive for 5 seconds. So this is the description of the motion. Therefore, if you find the area underneath this graph, which I will highlight now, this is the area underneath the graph, which is a triangle. You should notice that the area is 125 meters. It will tell you about the distance covered by the car. So again, we are applying what we have learned just now in this new scenario. So the displacement of the car at 5 seconds is therefore 125 meters. Let's put a mark or coordinate on the displacement time graph. So we have the car at 0 meters at the start, and after 5 seconds, the car is at 125 meters away from the origin. Now, let's apply the second key point that we have learned just now. The gradient of the displacement time graph tells us the velocity. So, from the velocity time graph, we notice that the graph is speeding up. The object is speeding up. So, this means that the gradient of this graph, this displacement time graph, must increase. It must become steeper and steeper and steeper with time. That is the reason why the graph should curve in this way, where at the start, if you look at the gradient of this point that I'm highlighting, the gradient is fairly gentle, but as time passes towards the end of the motion, looking at the part that I'm highlighting now, the gradient becomes steeper and steeper, indicating that the car is speeding up. For this scenario 3, we can do further analysis. So when we want to find the instantaneous velocity, we can easily find it by using the gradient of the graph, of the displacement time graph. Previously, we have worked with graphs that are straight lines. What happens if, in this case, you are given a curve? So, not to worry, the same rule applies. The gradient of a displacement time graph tells you about the velocity. So what you have to do if you are given a curve, you simply have to draw a tangent line. So look at the tangent line, and from the tangent line, finding the gradient will get you the instantaneous velocity of the object. So for example, at 5 seconds, we can figure out what is the instantaneous velocity at 5 seconds. So at 5 seconds, draw a tangent line, find the gradient, and there you go. The instantaneous velocity of the object at 5 seconds is 20 meters per second. We can do so at other points of the graph. So let's say if you're interested to find the velocity of the graph at 10 seconds. So same thing, at 10 seconds, draw a tangent line, which is the cyan line shown. Find the gradient of this, and you will get the value of the velocity. Now, applying what you learned just now. Okay, so again, the gradient of the graph actually becomes steeper and steeper with time. It started off fairly gentle at 0.1 on the slide, and then as time passes until 0.2, the gradient becomes steeper. So this shows that the object has speed up and become faster. So this tallies with our calculation over here that the final speed and the final velocity is actually much higher, much faster than before. For scenario 3, there's one new key point that we can derive. So I'll give you 5 seconds to find the gradient of this velocity time graph. Okay, so let's take a look. Gradient is again rise over run, and notice that when I use this coordinate and this coordinate, my rise is 50 minus 0 and my run is 5 minus 0. This actually resembles this equation over here, from which you should be able to derive that this is the acceleration. So this new key point is therefore on a VT graph, a velocity time graph. If you find the gradient, that should give you the acceleration value. So let's have one example to apply this. Say you want to find the acceleration at time equals to 3 seconds. In this case, you are not given a straight line but a curve, but not to worry. Again, use a tangent line to find the gradient. So draw a tangent line, identify two coordinates, and find the gradient. So from here, you can get the acceleration value of the object. So in summary, we have derived 3 key points for motion graphs thus far. So for motion graphs, you can derive this information from the gradient and the area between the graph and the time axis. So first up, on the displacement time graph, if you find the gradient, that should give you information on the velocity. That's what we have derived earlier. Now, there are some tips that I've put inside the video to help you. Make sure you copy it down. If your gradient is a positive value, positive gradient, this means that your velocity is therefore positive. This means, therefore, the object is moving towards the positive direction. Now, the reverse is also true, meaning that if you find that the gradient is negative, this means that the velocity is negative. What does negative velocity mean? It means that the object is moving towards the negative direction. Okay. Moving on, if you look at the velocity time graph, what does the gradient tell you? The gradient simply tells you about the acceleration. Take note again, you can have positive acceleration or negative acceleration. Lastly, on the velocity time graph, what would you get if you find the area between the graph and the time axis? Displacement of the object. Again, some detailed notes are given there, and it will come in very handy for you. So if you get positive area, now what is positive area? Positive area means that the area is above the time axis. This means your displacement is positive. What does positive displacement mean? This means the object has moved towards the positive direction. The reverse is again also true. If you get negative area, again, what does negative area mean? It means that the area is beneath and below the time axis. This means your displacement is negative. This means that the object has moved in the negative direction. So with this, we have come to the end of this video.